All right, get this. What if I told you there's a technology out there being used right now that can make gold literally float right out of solid rock? I know, it sounds like something out of an alchemy textbook, but trust me, it's 100% real.
And it's not just real, it is shockingly effective. I'm talking about a gold processing plant in Shandong, China that uses this very method to get a gold recovery rate of 92%. In an industry where every single speck of dust matters, that number is just wow. It means if there are 100 grams of gold hiding in a pile of rock, they get 92 of them out.
So, the big question, the one you're probably asking right now, is how? How is that even possible? Especially when you realize the gold they're going after is basically invisible. You can't even see it. To really get the solution, you've got to first appreciate the sheer scale of the problem. We're not talking about big, shiny nuggets. We're dealing with an invisible treasure locked away inside tons and tons of worthless stone. Yeah, so forget those movie scenes of people finding chunky gold nuggets. The gold being mined today is made of microscopic particles, way, way finer than a single strand of your hair. And they're not just sitting there, they're completely trapped inside other minerals. For all intents and purposes, they're part of the rock itself.
So, how in the world do you get it out? You can't just smash the rock harder. The answer isn't about brute force. It's about some incredibly clever chemistry. And believe it or not, it all comes down to the magic of bubbles. The technology is called flotation, and the core idea behind it is brilliantly simple. You basically forget about how heavy or big the minerals are. Instead, you separate them based on one simple property. Do they love water or do they hate it?
And right here, this is it. This is the entire secret to that mind-blowing 92% efficiency, all boiled down to one simple idea. You use a special cocktail of chemicals to make the tiny gold particles hydrophobic, which is just a fancy way of saying you make them absolutely hate water. This is a perfect way to picture it. On one side, you have the waste rock, all the junk you don't want. It's hydrophilic, meaning it's totally fine being in water. But on the other side, you've got our gold particles. After that chemical treatment, they've become hydrophobic. They can't stand being wet. And that one simple engineered difference, that's the key to the whole shebang. Okay, so we've got the principle down. Now let's walk through how it actually works in practice. This whole process of turning a pile of rock into a bucket of gold really comes down to 4 main steps. First up, you grind the ore into a super fine powder. You have to do this to physically break those tiny gold particles free. Then you mix that powder with water and that chemical cocktail we mentioned to create this soupy mixture called a slurry. Next, you pump a ton of air into it, creating a literal storm of bubbles. And finally, you just skim the good stuff, the gold-rich foam, right off the top. Let's just zoom in on that second step, though, the chemical cocktail, because this is where the real magic happens. They add what's called a collector. Think of it like a special glue that only sticks to gold, and this glue is what gives the gold that water-repellent coating. At the same time, they make the water more alkaline, adjusting the pH, which just creates the perfect conditions for that collector to do its job as effectively as possible. So once that slurry is all prepared and the gold is ready for its big escape, it's go time. The whole mixture gets pumped into these enormous tanks, and then whoosh, a huge amount of air is blasted in from the bottom, creating this churning, bubbling chaos inside.
And this is where that beautiful separation happens. The tiny gold particles, now despising the water all around them, see the air bubbles as little escape pods. They latch onto the surface of the bubbles and ride them like an elevator all the way to the top. Meanwhile, all that waste rock is perfectly happy in the water, so it just sinks right to the bottom. It's so elegant.
And the result is, well, it's pretty spectacular. The source material puts it perfectly. A layer of golden foam floats to the top, like a bubble bath of treasure. And that foam is just jam-packed with all those microscopic gold particles we've been trying to catch. So all of this complicated chemistry, the massive engineering, why go through all that trouble? Well, let's talk about the real-world payoff, because it is huge. Here's the most crucial point. Flotation makes it profitable to mine rock that has incredibly tiny amounts of gold in it. We're talking about ore that just a few decades ago would have been considered completely worthless. Now, thanks to this process, it's a valuable resource.
This chart really nails the concept. You start with that massive bar on the left, a huge volume of low-grade ore. Then you put it through flotation and you end up with that tiny little bar in the middle, a small but incredibly valuable gold concentrate.
You're essentially turning a mountain of rock into a handful of treasure. Which, of course, brings us right back to where we started. That 92% recovery rate from the Shandong plant, it's not just a number. It's a testament to just how insanely refined and efficient this whole process has become. It's the direct result of perfecting every single one of those steps we just walked through. So this amazing technology is solving today's problem of how to get at microscopic gold. But it leaves you with a really fascinating question to chew on, doesn't it? As natural resources get even harder and harder to find, what kind of new, even more ingenious methods are we going to have to invent for the future?